Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem using the method of undetermined coefficients. So let's get going. Problem: solve y double dash plus 6y dash plus 5y equal to 2e power x plus 10e power 5x. So we are given a differential equation and we are asked to solve the problem using the method of undetermined coefficients. Firstly, just consider the given equation. We can write y double dash as d square y by dx square plus 6 into write y dash as dy by dx plus 5y equal to 2 e power x plus 10 e power 5x, right? Also, we can write d square y by dx square as capital D square y, where d is a differential operator. We'll get d square y plus 6 dy plus 5y equal to 2 e power x plus 10 e power 5x, right? Now take y common from all the three terms of LHS. We'll get d square plus 6d plus 5 into y equal to 2 e power x plus 10 e power 5x, right? Which is in operator form. So we can write the given differential equation in operator form d. Say f of d into y equal to some function of x. Okay. You can ask the equation in operator form also. Fine. Now coming to the problem. Solution: given equation y double dash plus 6y dash plus 5y equal to 2 e power x plus 10 e power 5x, or d square plus 6d plus 5 into y equal to 2 e power x plus 10 e power 5x, which is in operator form. F of d into y equal to some function of x, say q of x, okay, where f of d equal to d square plus 6d plus 5 and q of x equal to 2 e power x plus 10 e power 5x, right? Now we need to find the general solution to the given problem, which is given by y equal to yc plus yp. Here we'll find yc using the auxiliary equation. Later we'll go for yp. We can find yp using the direct formula or with the help of trial method. Okay, we'll see the two cases. Now coming to the auxiliary equation. Consider the given equation as equation number 1, right? Fine. The auxiliary equation is f of m equal to 0, where f of m equal to, we have f of d square plus 6d plus 5, right? Let's replace differential operator d by m, so that we'll get f of m equal to m square plus 6m plus 5. Now the auxiliary equation becomes m square plus 6m plus 5 equal to 0. Now we need to find roots to this equation. Let's split 6m as 5m plus m or m plus 5m, whatever. Okay, take m common from the first two terms, you'll get m times m plus 1. Take 5 common from the next two terms, you'll get 5 times m plus 1 equal to 0. This gives us m plus 1 into m plus 5 equal to 0, right? See, if you take m plus 1 common, you'll get m plus 1 into m plus 5, right? Now, equate each factor to 0. Equate each factor to 0. You'll get, when m plus 1 equal to 0, m equal to minus 1. When m plus 5 equal to 0, m equal to minus 5. Therefore, the roots are real and distinct. That is, minus 1, minus 5 are real and distinct roots to this auxiliary equation. Now with the help of these roots, we'll find the complementary function. When two roots say m1 and m2 are real and distinct, then yc looks like one constant into e power 1 root into x plus another constant into e power another root into x. Now, coming to our complementary function, we have two roots, right? c1 e power 1 root say minus 1 into x plus c2 into e power another root say minus 5 into x, which gives us yc equal to c1 e power minus x plus c2 e power minus 5x. Therefore, yc equal to c1 e power minus x plus c2 e power minus 5x. Now we have yc equal to c1 e power minus x plus c2 e power minus 5x and q of x equal to 2 e power x plus 10 e power 5x. Just observe the terms of yc and q of x. In yc you are having c1 e power minus 2x, c2 e power minus 5x, and in q of x you are having 2 e power x, 10 e power 5x, right? Or just consider the functions of x: e power minus x, e power minus 5x, e power x, e power 5x, right? We don't have any common terms. That is q of x, the terms of q of x has no common term with yc. Therefore, q of x has no common term with yc, right? Now coming to the yp. Therefore, yp must contain the linear combination of q of x and all its linearly independent derivatives. Right? Fine. Let's see the direct formula. When q of x is some e power ax, then yp will be some constant, say a into e power ax. Okay, here a varies. Here in q of x we are having 2 e power x. Just neglect the coefficients of functions of x. Okay, in q of x we are having e power x, right? For e power x, the formula will be one constant into e power x plus we have another term which involves e power 5x. For e power ax, your yp will be e power x with some coefficient, say b. This is the direct formula with the help of formula. Okay, so this is a yp when q of x is 2 e power x plus 10 e power 5x. Okay, for a equal to 1 and for a equal to 5. Here we are having two functions, right? E power x and e power 5x. So you'll have two formulas, I mean two terms in yp for e power x and for e power 5x. Don't get confused. Fine. This is a formula with the help of the direct formula. Okay. Now coming to the trial method. Let's see the trial method now. Just take the term of q of x, one term of q of x. I'll take e power x. Okay, I'll just neglect the coefficient of e power x, which is 2. Now see, as I said you earlier, e power yp must contain the linear combination of q of x and all its derivatives. Okay, this is a term of q of x, right? So yp should contain e power x and all its derivative. What is the derivative of e power x is e power x. Again, derivative of e power x is e power x. Okay, you'll just get e power x. I mean, if q of x is e power x, then q dash of x is e power x. Again, q double dash of x is e power x, q triple dash of x will be e power x, and so on. It just continues. You'll get e power x. All the derivatives of e power x is just e power x, right? Now, coming to the next term, e power 5x, right? Yp should contain e power 5x and all its derivatives. So find the derivatives of e power 5x. Derivative of e power 5x is 5 e power 5x. Again, find the derivative of 5 e power 5x. 5 5 is a 25 e power 5x, right? Again, find the derivative of it. 25 5 is 125 e power 5x. It's 5x, okay? E power 5x and so on. Okay. Now, we'll write q of x, that is terms of q of x and all its derivatives in set form. Okay, we'll write q of x and all its derivatives in set form, and remember that the set should not contain repeated terms. Okay, so it should contain, see how many e power x we have, 1 2 and so on, right? Only e power x and e power 5x. See, simply q of x and its derivatives has e power x and e power 5x. There is no other term or any other functions of x other than e power x and e power 5x, right? So here in this set we'll have only two terms. One is e power x and another is e power 5x, right? See, the set involves q of x and all its derivatives. Q of x, term of q of x, term of q of x, and all its derivatives involves, derivative of e power x involves only e power x, and derivatives of e power 5x involves only e power 5x. Okay, forget about the coefficients of e power 5x and e power x. Okay, so the set involves only e power x and e power 5x, right? Now, with the help of this set, we'll write yp, the formula. Okay, so first pick e power x with some coefficient, say a, plus, now write the another term e power 5x with some coefficient, say b. This is the formula yp. So we have chosen yp such that it satisfies the given equation. So we can write the given equation in terms of yp. Okay, fine. Now we got yp. Here a and b are the undetermined coefficients. Okay, we have to find a and b values. Fine. Now coming to the problem, let yp equal to a power x plus b power 5x. Okay, such that it satisfies the given equation. So we can write one as yp double dash in, you can write 1 in terms of yp. Yp double dash plus 6 yp dash plus 5 yp equal to 2 e power x plus 10 e power 5x, right? So in this equation we have yp dash and yp double dash, but we have only yp, and now we need to find yp dash and yp double dash, right? Let's find yp dash and yp double dash. Yp dash is a into derivative of e power x is e power x, plus b into derivative of e power 5x is 5 e power 5x, which gives us a e power x plus 5b e power 5x, right? Now coming to yp double dash, which gives us a into derivative of e power x is e power x plus 5b into derivative of e power 5x is 5 e power 5x, right? This gives us a e power x plus 5 is a 25b e power 5x. Now we got yp dash and yp double dash, right? Now substitute yp double dash, yp dash and yp in this equation. 1 becomes yp double dash plus 5 yp dash it's 6, right? Sorry, 6 yp dash plus 5 yp equal to 2 e power x plus 10 e power 5x. Now write values of yp, yp dash and yp double dash. Just substitute yp, yp dash and yp double dash here. We'll get a e power x plus 25b e power 5x plus 6 times yp dash a e power x plus 5b e power 5x plus 5 times yp a e power x plus b e power 5x equal to a e power x plus 25b e power 5x, right? Now simplify it. You'll get a e power x plus 25b e power 5x plus 6a e power x plus 6 5s are 30b e power 5x, it's b, plus 5a e power x plus 5b e power 5x equal to the RHS part. This gives us a e power x plus 6a e power x plus 5a e power x gives 12a e power x. Now add the terms involving b e power 5x, 25b e power x plus 30b e power 5x, it's e power 5x, right? Plus 30b e power 5x plus 5b e power 5x. 5 plus 25 30, 30 plus 30 60. You get plus 60b e power 5x equal to a e power x plus 25b e power 5x. We have covered all the terms, right? See here, the RHS part is 2 e power x plus 10b. Sorry, it's 2, 10. It's 10, right? 10 e power 5x. Fine. Now equate the equations of like terms. Okay, I'll begin with e power x. Equate the equations of e power x. We'll get 12a equal to 2, which gives us a equal to 2 by 12. 2 ones are 2 6 are. Therefore, a equal to 1 by 6. Now equate the terms, equate the equations of e power 5x. We'll get 60b equal to 10, which gives us b equal to 10 by 60. 1s are 6 are, therefore b equal to 1 by 6, right? We got the values of a and b. Now coming to yp, we have yp equal to a power x plus b e power 5x, right? This gives us yp equal to a 1 by 6 into e power x plus b 1 by 6 into e power 5x, or just take 1 by 6 common from these two terms. You will get 1 by 6 into e power x plus e power 5x. So we got yp now. So you can verify yp using 1 by f of d into q of x. Okay, fine. We got yp and yc. Let's now find the general solution using the formula y equal to yc plus yp. Therefore, the general solution is given by y equal to yc plus yp is equal to y equal to yc c1 e power minus x plus c2 e power minus 5x plus yp 1 by 6 into e power x plus e power 5x, or So if you take first root as minus 5 and second root as minus 1, you'll get y equal to c1 e power minus 5x plus c2 e power minus x plus yp. Okay, this completes the problem. Well, we have seen a problem using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.